Today we are going to study the chapter under physics, electricity. In this chapter, let me know simple definitions on what is electricity, what is circuit, what is electric potential, and what is potential difference, and many more concepts under chapter electricity. We commonly observe when we switch on the light, very immediately we can observe the glowing of the light or running of the fan, etc. How this can be possible? This can be possible only by the flow of charges. And the flow of charge is nothing but electricity. The amount of flow of the charge in a particular area in a unit time is known as electricity. And this is represented as I is equal to Q by T. The flow of electric charge always utilizes the energy in a form called Coulomb. The Coulomb is a unit of electric charge and it is measured in a time called seconds. The 1 Coulomb is required to flow the electric current in a unit time. So this is I is equal to Q by T. So what is electricity? Electricity is the amount of the flow of the charge in a particular area. What kind of area it requires? It is nothing but conductor. Only the conductor can conduct the electricity in a particular area in a unit time. The time is represented by seconds and the charge is represented by the Coulomb. And there is a standard value for each Coulomb. Each Coulomb is represented with the constant value, that is 6 into 10 raised to 18 electrons. This is about the electricity. And where do the electric charge will flow? And what kind of charge will flow? This will be represented with a circuit diagram. Now I am going to write a circuit diagram. So here there will be battery, otherwise called potential difference. So the long line is represented as positive terminal and the small line is represented as negative terminal, and this is called, and here connected to an electric bulb and ammeter, key connected to the negative terminal. Now how, in which direction the electricity passes? It flows through an positive terminal. So by this electric circuit we can explain that the flow of electric charge, that is positive charge, is representing the flow of electric current, and always it flows in an opposite direction of negative terminal called flow of electrons. Always the electrons flows in opposite direction of the electric current. So this is I, electricity, electric current, that is in the direction of positive terminal, and this is ammeter. Ammeter is an instrument used to measure the flow of electric current, and it is connected to the key or switch to on and off. And here the negative terminal, here this is the flow of electrons. So clearly the diagram shows the electricity, the flow of electric current is opposite to the flow of electrons. So this is about the circuit. A continuous and closed path of electric current is known as electric circuit. Either it is flowing continuously or it has been closed. Anyhow, it represents the flow of current or the path of the current. So this represents the electric circuit. Let me see one numerical under the formula I is equal to Q by T. Now the problem is like this. 0.5 ampere. What is this ampere? A-M-P-E-R-E. What is this ampere? Ampere is unit of the electric current. 0.5 ampere utilized by the bulb for about 10 minutes. Then find out the amount of flow of the charge in a circuit. Now, we want to find out the amount of charge in a circuit that is not given. The time is given 10 minutes. But I already said it should be measured in the form of seconds. Immediately you convert into seconds. 10 into 60, that is 600 seconds. Okay. And what is the current? 0.5 ampere. Now I want to change this formula, that is I is equal to Q by T. Q is not given, I is given, T is given. So bring Q towards left and then it will become I into T. Q is equal to, what is I? 0.5. What is T? 600 seconds. When you multiply 6 5s are 30, it becomes, and decimal after one new number. So that is 300 coulomb. So based on this formula, definitely you may have problem under MCQ or it may be asked under 2-mark question. Electric potential. The electric potential is the difference between two endpoints in a circuit as work done to move unit charge is known as electric potential. It is nothing but the difference between two endpoints in a circuit with the flow of current as the work done to move a unit charge in a unit time is known as electric potential. That is V is equal to W by Q. V is nothing but potential difference, W is work done and Q is the charge utilized. Now always the potential difference is measured in the term the work done to move the charge. The work done to move the charge is known as potential difference. And the potential difference is V is equal to 1 joule by 1 coulomb. Same. Work done, the unit is joule. Coulomb, the unit is, charge is, unit is coulomb. Work done, always measured with the joule unit. And charge is measured with a unit called coulomb. So V is equal to W by Q. In the same manner, the potential difference is V is equal to 1 joule by 1 coulomb. In order to complete the work of 1 joule by completing or utilizing 1 coulomb is nothing but the potential difference. So based on this, definitely there will be problem, and obviously the numericals will be applied on the particular terms, and what is not given, you just put a question mark and just change the formula and make with the sum.
Sorry.
Now let me know Ohm's law. This is very important. What is Ohm's law? We know V is potential difference. The potential difference is directly proportional to the current passing through the conductor, I into R. This is known as Ohm's law. Ohm's law is very simple. The potential difference is directly proportional to the current flowing through the conductor. And I didn't say about R. Why? R is constant. And what is R? R is nothing but resistance. Why I didn't consider here R? Why it is kept constant? Because resistance is always, for any metallic wire, it is totally depending on the length. It depends on the length, and it depends on the area of cross section, and it depends on the nature of material. That means I is equal to, it is directly proportional to the length. I. R is directly proportional to the length, L. Inversely proportional to the area of cross section. This is called resistance. And always this is represented by the Greek term ohm. This is a unit used to represent the resistance. And the other way to write this R is equal to, R is directly proportional to the length, inversely proportional to the area of cross section of the conductor, whereas R is equal to the rho, this is called rho, and L by A. What is this rho? This rho is nothing but resistivity. Rho is nothing but resistivity. This about the Ohm's law. See, Ohm's law, where the potential difference is directly proportional to the current flowing through the conductor, and always R kept constant. What is R? R is nothing but resistance. Why it is kept constant? Because resistance of metallic wire, it depends on three factors. That is, length, it is directly proportional to the length, inversely proportional to the area of cross section, and depends on the nature of the material. So R is directly proportional to L divided by A, directly proportional to the length, inversely proportional to the area of cross section, and always it is represented by the unit called ohm. And same resistance, we can have little slight variation. R is equal to rho L by A. What is this rho? Rho is, that is resistivity. Resistivity. R is resistance, rho is resistivity. This is about the Ohm's law and its formula. Ohm's law can be applied for different combinations of resistors. How to represent that? So, Ohm's law can be applied for the combination of resistors, just now I said. And what are these combinations? Now, Ohm's law can be applied for different combination of resistors. And what are this combination of resistors? The combination of resistors are maybe in series or maybe in parallel. So this is called the combination of series, and this is known as combination of parallel, and this should be connected for the electric circuit. Now, previously I said how to draw the electric circuit. Draw the battery, positive, negative, and connect this, the flow of electric current. And here I said ammeter, and then key, and then connect to the negative terminal. This is series circuit diagram. And here R1, R2, R3. These are the combination of resistors. How it is arranged? It is arranged in series. In the same manner, you complete this. What do you want to suppose to write? Battery, then ammeter, key. So here R1, R2, R3. This is the combination of resistors. Here easily we can apply the Ohm's law. Very easily you can calculate what is the total resistance of the electric circuit. Let me see the formula for this to calculate. Now R1, always I said resistance is measured with the unit called ohm. R1 may be 10 ohms, and this may be 20 ohms, and this may be 30 ohms. Think the electric current, it is in a decimal or in a whole number. 1 ampere. And usually the voltage, it is about 60 volts. Imagine. Now, what is the total resistance? Can we apply the Ohm's law? Yes, definitely we can apply the Ohm's law. What is the Ohm's law for this? We know V is equal to I into R. But this is total resistance. But we have the combination of resistors. Is there any formula for this? Yes. The total resistance is R is equal to R1 plus R2 plus R3. This is the formula of combination of resistors to make it as a total resistance. Now apply this number. R is equal to 10 plus 20 plus 30. What is the total number? 60 ohms. 60 ohms. Now apply this 60 in the place of R. Now calculate. Apply the Ohm's law. V is equal to I. What is I? 1 ampere into R. How many? 60 ohms. So 1 into 60 is 60 volts. So this is about the potential difference. Okay, in the parallel combination of resistors, now voltmeter V1 is connected separately, V2 is separated, and V3 is separated. The flow of the current is common, but the voltage varies. Why? The resistance capacity varies. Hence, the voltage also varies. In order to calculate the separate voltage for each resistor is, that is, V1 is equal to I into R1, V2 is equal to I into R2, V3 is equal to I into R3. Easily now we can calculate V1, V2 and V3, right? Because we have common current here, 1 ampere, and separate resistance, separate numerical number, and easily we can get the V1, V2 and V3. Let me calculate this. V1 is equal to 1 into R1 is 10. That is 10V. And second one is 20V. and third one is 13. Total this 60. Now we will get 60 voltage. Now in a separate or in a combined form, the voltage will be common. If you separate this, now total number of all for V1, V2, V3, it should common with this voltage. Like this we can apply the Ohm's law in order to calculate the combination of resistors in series. In the same way, even the problems may be asked in parallel series. How I done the problem with the series, in the same manner we can have the problems in the parallel combination of resistors. Now how to calculate this? For the series, it's very simple. R is equal to R1 plus R2 plus R3. But for the parallel, it is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now here the voltmeter is kept common for all the resistors. But current may vary I1, I2, I3. Now can we apply the Ohm's law here? Yes. Same, you take the same number, 10 ohm, 20 ohm, 30 ohms. And how to calculate the common resistance? Now 1 by R is equal to 1 by R1, that is 10 ohm, plus 1 by R2, that is 20, plus 1 by 30. Take the LCM for this. 10, 20, 30, 10 ones are, 10 twos are, 10 threes are, 3 twos are 6, 6 tens are, 60 is 10 six are, 2 threes are, 3 twos are, 6 plus 3, 9, 9 plus 2, 11, 11 by 60. This is 1 by R. Then what is R? You just reverse it. 60 by 11. You just divide 5.45. So this is resistance, represent with the unit ohm. So this about how to calculate the resistance when it is connected in a parallel connection. That is 1 by R1 plus 1 by R2 plus 1 by R3. This is the formula we use. In the same manner, electric current also varies for each resistor. That is, for R1, the current may be I1, for R2, I2, for R3, I3. So like this, the current varies when it is connected in a parallel. But here in the series, same current is flown through in a series circuit, but different current flows in a parallel circuit. But what about voltage? Here voltage will be common. In the parallel connection, the voltage will be common, but here the voltage varies. So the voltage varies in the series, same voltage used in the parallel. In terms of current, so same current is flown in series, and here the current varies when it is connected in the parallel. This about the combination of resistors and how to apply the Ohm's law when it is in a combination. So either it is in series or in a parallel. Many times we see that the circuit is being connected with the battery or the cell. What is the use of connecting battery or a cell? It provides energy in the form of electricity. Now why energy is required? Battery is connected to the circuit to perform certain activity in order to glow the bulb or to run the fan, etc. So we need energy, and to supply the energy we connect the battery or a cell. How the electricity is generated in a battery or a cell? So it takes place certain chemical reaction within the cell and creates potential difference. And due to that potential difference, the flow of the charge occurs. As a result, the circuit is connected with the electricity or current. This is the importance of battery or a cell, why we use in the circuit. Now, you are going to know what is heating effect of electric current. So, many times we see that as soon as we switch on the light, light glows. You just be observing the light after 1 or 2 hours. So, we feel little bit high temperature when we get closed in a room because the light goes on glowing. So, certain amount of energy transfers into heat and that increases the temperature. We feel suffocation inside the room. And many times you will be observing when you switch on the iron box, immediately it heats up. The temperature increases, and that is also because of heating effect. What is heating effect in an electric current? Certain part of energy is completely consumed, and that consumed energy transfers into heat, and that effect is known as heating effect. Now this can be denoted with the formula H is equal to V into I. Even you can represent it as P is equal to V into I. And what is the formula for I? We already studied. The formula for I is, what is the formula for I? V is V into I. In the place of I will write as Q by T. So H is equal to V into I. That way equal to the V into Q by T, as I is equivalent to Q by T. You can represent the formula P is equal to V into I. There is a law called Joule's law of heating. By applying the Ohms law here, we can represent H is equal to I square R into T. This is known as Joule's law of heating. H is equal to I square RT. This is very important for examination purpose. It will be asked what is Joule's law of heating and represent the formula. H is equal to I square R into T. What this indicates? The heating effect is directly proportional to the square of the current flowing through the circuit, directly proportional to the resistance and directly proportional to the time. So this is known as Joule's law of heating. H is equal to I square R into T. What is the application of heating effect in our daily life? We use electric iron box, toaster, kettles, heaters, all this because of heating effect. So here some part of energy of electric current is completely transformed, consumed for increasing the heat. Electricity is transferred into heat, and that is known as heating effect. Even this can be applied in the fuse. So 220 volts is a common domestic supply of the current. When it increases more than 220 volts, the fuse increases its temperature, it melts and it disconnects, so that it protects the house from short circuit. So this is how the heating effect we find in our daily life. And there is a term called power. What is power? Electric current is completely consumed into heat. It is completely utilized, and the utilized form is known as power. The complete consumption of electric current for domestic purpose is known as power. What is the formula for power? Again, I wrote P is equal to V into I. Even it can be represented as P is equal to I square R. So P is equal to V into I, P is equal to I square R. Both the formulas can be applied in order to calculate the power. What is the unit for power? Watt. Watt is a very small unit. Usually will represent as kilowatt. Kilowatt we commonly use, but watt is the smallest unit. That is the unit for the power. Now we will go with the small numerical. Now how to calculate the power? 20 volts of energy is supplied to the bulb and 0.5 ampere of the current is utilized. Calculate its power. Now what is the formula for power? P is equal to V into I. Same thing you can apply here. P is equal to V into I. V is 220. I is 0.5. Just multiply it. 5 zeros are 5 2s are 10. 5 2s are 10 plus 1 11. So keep one decimal after one digit, that is 110 watts. This is about the numerical on power. So this about the electricity chapter. Mainly the questions are asked on Ohm's law, potential difference, and combination of resistors in series and parallel, numericals on that, and heating effect, numericals on heating effect, and mainly they'll ask on Joule's law of heating and the formula, and formula should be expanded neatly, and what is power and how to calculate the power. This completes electricity, and hope good marks will be scored in this chapter.
The first one represents the symbol for cell or battery. The second one represents the series of battery. The third one represents the switch which is open. The fourth, the switch which is closed. And the fifth one, which represents a wire with joint. Sixth, the wires crossing without joint. Seventh one, it represents the symbol of electric bulb. Eighth, resistance. And next, rheostat, ammeter, voltmeter. This chart shows the resistivity of conductors, alloys and insulators. Usually the conductors have very less resistivity, alloys has moderate resistivity, and insulators will have very high resistivity. The conductors have low resistivity and hence they conduct electricity very fast. Alloys moderate. Insulators, they have more resistivity and hence they cannot conduct electricity. So high resistivity, flow of the current will be less. Low resistivity, high conduction of electric current. This is circuit diagram, and the question may asked in different manner, like what is the missing part in the circuit, or the labels may be given in the question but you want to draw the circuit for the given data. So like this the questions may asked on circuit.